Data cleaning and coding are based on the questionnaire, which has 5 sections A to E. For section A, demographic section, the coding is as follows. For question number 1, 1 stand for yes, 2 stand for no. Question 2, follow the same coding as question 1, which is 1 stand for yes, 2 stand for no. Question 3, 1 stand for male and 2 stand for female. Question 4 is each group which have 1 to 5. 1 stand for 18 to 24 years old. Number 2, 25 to 34 years old. Number 3, 35 to 49 years old. Number 4, 50 to 64 years old. And number 5, over 64 years old. And other questions in section A is use number codes based on the answer options given in the questionnaire. For section B, C, D, and E, this section use a rating scale from 1 to 5. The meaning of each number is 1. Strongly disagree. 2. Disagree. 3. Neither agree nor disagree. 4. Agree. 5. Strongly agree. In this section, the respondent answer are coded using these numbers, and the result will show in average score between 1 to 5 for each variable.
For frequency, firstly we need to go to analyze, and then descriptive statistic, and then frequency. Okay. Select your categorical variable, move it into variable box like this, and then click OK. This is the frequency output, which tell you how many times each category appears in the data. State, age, district. Okay, next is descriptive statistic for continuous variable. First, we have to click on analyze, and then go to descriptive statistic, and then choose descriptive. Select all the continuous variable you want and move them into the variable box. And then next, click on the option buttons. Make sure to tick mean, standard deviation, minimum, maximum, skewness, and kurtosis. And then click OK. The result will appear. If the skewness or kurtosis value below 1.00, your data is likely normally distributed, or at least not too skewed. Okay. To calculate the z-score for skewness, divide the skewness value by its standard error. For example, if the skewness is negative 0.184 and the standard error is 0.149, then must be divided 2 of the, and then equal to negative 1.24. Okay, to compute the variable, firstly we have to put the target variable. For example, is ATT total is main attribute to attract total, and then put the track 1 until attract 3. And then we must divide it based on the attraction have. Okay, for this label we need to put the right total, and then this is the output. Click analyze, and then descriptive statistic, and then explore. Okay, click the variables you are interested, like attract total. Okay, for the box plot, okay, for the box plot, click the histogram, and then click the normality plus with test, and then click for the continue, and click continue, and then for option, click for the exclude cases pairwise, and then continue, and then select OK. Okay, this is the output of the descriptive The descriptive histogram, plot attract total, and the box plot. The box plot of this video shows the east whisker of top of the box longer than underneath the box. It says positively keywords.
Menu, click Analyze, go to Scale, click Reliability Analysis, insert the variables you want to test. For example, if you have 5 items, put all 5 into the items box. Make sure model is set to alpha, click Statistic, then under Descriptive for, tick Item, Scale if item deleted. Under Intel Item, tick Correlation, then click Continue, and finally click OK. After that, look at 2 tables. One is Case Processing Summary, and 2 is Reliability Statistic. Check the value under Crunchband's alpha. Below 0.5 is poor, 0.5 to 0.7 is moderate, 0.7 to 0.9 is high, and above 0.9 is excellent.
Next, hypothesis testing. For the hypothesis testing, we use multiple regression. 2 questions will be addressed for this method. Question number 1. How well do the 5 independent variables, which is aesthetic appeal, layout and functionality, social factor, destination attractiveness, and destination familiarity predict travel intention? How much variance in the travel intention scores can be explained by scores on these 5 scales? And then question number 2. Which is the best predictor of travel intention? Aesthetic appeal, layout and functionality, social factor, destination attractiveness, or destination familiarity? First thing first, to do multiple regression is to click Analyze, click Regression, click Linear, and then click Continuous Dependent Variable, which is travel intention, and move into Dependent box. And next, click on Independent Variables, such as aesthetic appeal and etc., and click on the arrow and move into independent box. For method, select Enter and click on Statistic button, select Estimates, Confidence Intervals, Model Fit, Descriptive, Part and Partial Correlations, and Collinearity Diagnostics. In Residuals section, select Case-wise Diagnostics and Outliers outside 3 standard deviations. Click Continue. And next, click Option button. In the Missing Values section, select Exclude Cases Pairwise. Click Plots button. Click ZRESID and move into Y box, and then click on ZPRED and move into X box. And the section headed Standardized Residual Plots, tick the Normal Probability Plot and continue. And then next, click Save button. And the section labeled Distances, select Mahalanobis and Cooks. Click Continue and then click OK. And then you will see the results coming out. How do we interpret the results is by checking the assumptions multicollinearity first. First, check the table level correlation. Check that every independent variable and dependent variable have a relationship, which is preferably to be above 0.3. As we can see here, every IV and DV have a relationship above 0.3, and if the correlation is 0.7 or above, do consider to compute the variables into one variable. In this table, every DV and IV correlation is under 0.7. Next, check the table labeled coefficients. There is tolerance and VIF column at the right side of the table. Tolerance is an indicator of how much the variability of the specified independent is not explained by other IV. If the value is less than 0.10, it indicates the multiple correlation with other variable is high, suggesting the possibility of multicollinearity. As you can see in the table, all the values in the tolerance column are above 0.10, and if the value of VIF is above 10, it indicates multicollinearity. Next step, we check the outliers and the normality in the scatter plot. If most of the scores concentrated in the center, which is 0.0, it is good. In this scatter plot, it shows that most of the scores are saturated in the center, which is good. But the presence of outliers can be detected from scatter plot. And how do we detect outliers is by checking any scores located more than 3.3 and less than negative 3.3. If you only find a few, like the scatter plot like ours, it's not necessary to take any action, just leave it be. Next, we look into model summary table. First, check the value under R² column. This tells you how much of the variance in TV, travel intention, is explained by the model, which includes aesthetic appeal, layout and functionality, social factor, destination attractiveness, or destination familiarity. The value under R² must be converted into percentage, which is multiplied by 100 and shifting the decimal point 2 places to the right. The percentage explains how much of the variance in DV. In this case, it's 35.5% of how much the independent variables variances in DV. Next, we look at ANOVA table. Check the significance value at the right side of the table. If the value is below 0.05, it indicates the model is significant and strong. In this case, the significance value is 0.000, which shows it is a very strong model. So, from all the steps we did earlier, it's to answer the first question, which is how well do the 5 independent variables predict travel intention, and how much variance in travel intention scores can be explained by scores of these 5 scales. And from it, we can say that the 5 independent variables greatly explain travel intention. Next, to answer the second question, which of the 5 independent variables best predictor of travel intention? First, to evaluate each of the IV, we go back to coefficient table. Check the column labeled beta under standardized coefficients. Find which beta value is largest among the IV and ignore any negative signs at the front. In this case, the largest value here is destination familiarity. The variable that have more larger value makes strongest unique contribution to explain the DV than the variable that have less value. Destination familiarity have more unique contribution to explain travel intention more than aesthetic appeal, layout and functionality, social factor and destination attractiveness. Next, check the value in significance column at the same table. If the significance value is less than 0.05, the variable is making a significant unique contribution to the DV. If the significant value is larger than 0.05, the variable is not making significant contribution to DV. In this case, destination familiarity also have shown 0.000, which is making a significant unique contribution to travel intention. That's all for our presentation. Thank you.